The Earth is facing the enhanced greenhouse effect, driven by non-renewable energy sources that contribute to global warming and climate change. Although renewable energy sources like wind, hydro, and solar power exist, traditional solar panels have significant environmental drawbacks, including containing toxic chemicals, a large carbon footprint, and taking up large amounts of useful land to produce energy. A potential solution is an environmentally friendly, transparent solar panel that could be used vertically as windows on buildings and skyscrapers to address the issue of excessive areas of forested or agricultural land being taken up by solar farms. Currently, some scientists are working on inventing a transparent solar cell. However, the existing experimental transparent solar cells have limitations such as being made from toxic materials, having low levels of efficiency and transparency. However, there is still the issue that the traditional solar panels are not environmentally friendly. Dye Sensitised Solar Cells, DSSCs, which use tin oxide-coated glass, titanium dioxide, a dye, and graphite to produce solar energy, are an environmentally friendly solution, being made from materials that are not harmful to the environment and fully recyclable. DSSCs are still experimental and not currently commercially available. The solar glass window is a prototype transparent DSSC that is powered by chlorophyll. To make the DSSC transparent, the opaque components of the DSSC, the dye, titanium dioxide, and graphite, need to be developed. The dye in the DSSC is the critical component that is needed to produce electricity. The voltage produced by the DSSC depends on the dye that is used in the cell. Chlorophyll, which is found in all green plants, are cells that help the plant absorb the sun's energy during photosynthesis. Extracted chlorophyll is largely transparent. An investigation looked at whether chlorophyll extracted from spinach and other plants produced different voltages in a DSSC. The investigation concluded that a DSSC with higher concentrations of chlorophyll produced more voltage. So, transparent chlorophyll was a suitable substitute for the dye component of a transparent DSSC. Graphite and titanium dioxide are both opaque materials. Making the materials transparent using a chemical process of substituting the components with other materials was not possible. So, inspiration was gained from perforated vinyl signage, commonly seen as advertisements on bus windows, as an engineered solution to transparency. The idea was to apply titanium dioxide and graphite in a way that had thousands of tiny perforations so that it was possible to see through. Industrial processes are set up to be able to do this. However, to make this in a lab or at home without industrial digital printers was a challenge. Many hours of extensive trialing and prototyping of different application methods were undertaken with many failures. However, this allowed the invention to evolve through the design thinking process. Graphite powder was converted into conductive graphite paint when mixed with acrylic glaze. While experimenting with testing the conductivity of this paint, it was found that once dry, the paint layer was able to be peeled off the glass it was painted onto. This was a turning point in the design and opened up a new opportunity to explore turning both of these chemicals into acrylic sheets that were able to be perforated with a laser cutter. Different formulations for graphite acrylic sheets and titanium dioxide acrylic sheets were trialed and tested so that a thin, even, and flexible acrylic sheet was made. The sheets were laser cut on a bed of cardboard with 4mm holes arranged in a diamond pattern to create the perforated acrylic sheets. While 4mm is a larger hole size compared to the perforated vinyl size hole of 1.5 to 2mm, the laser cutter used had limitations and this was the smallest size possible. A first prototype DSSC was made at 100 by 100mm using the perforated graphite acrylic sheet, titanium dioxide acrylic sheet, and chlorophyll. The voltage of this DSSC was then tested successfully, clearly demonstrating the design as a good working concept. A second, larger format prototype DSSC, the solar glass window, was then constructed. When tested, the solar glass window prototype produced a 19.9 volts at 900 seconds and had a 41.8% efficiency, compared with a commercial solar panel with 20.3 volts at 900 seconds and 42.6% efficiency. This successful prototyping and tested showed that the solar glass window is a viable alternative to replace traditional solar panels.